For today's class, we are going to cover how to solve inequality word problems. The last few classes we covered, the first class dealing with this, we covered solving inequalities, one-step inequalities. Then we did solving and graphing multi-step inequalities. And the next step in the process is to solve these word problems, these real-world application problems dealing with inequalities. We've had a few examples of them, and by and large, it seems like the majority of you are struggling a little bit with them. So that's what the bulk of today is going to be about. It's going to be solving inequality word problems. So let me go ahead and share my screen with you all so you can see what I see. All right, here we go. Solving inequality word problems, lesson 2-3 or notes 2-3. Once again, you're going to open up your copy of the notes in Kami. I want you all to use Kami because it makes it easy to grade. It makes it easy for you all to annotate. So open it up in Kami. If you're having troubles, let me know. But open up in Kami and follow along with me. So we're going to spend this day, like I said, solving inequality word problems. And quite a few of you all, the last few times we were using Kami, weren't quite sure about how to get the less than or equal to or the greater than or equal to signs. You can just type in less than or equal to or greater than or equal to if you like, and that's perfectly okay. I'll know exactly what you mean. It may not look the best, but I will know what you mean. So with that addressed, let's read the directions. The directions say, follow along, setting up each problem and then writing your solution. Okay, I want you to write out my solutions, going step by step with me, and then at the end, you all will have some problems to do yourselves. But before we get into that, quick reminder, let's look at this stuff right here. This is on the first set of notes, this stuff here. The words and phrases that indicate what inequality operations we should be doing. We have less than and fewer than, greater than and more than, at most, no more than, and less than or equal to, at least, no less than, and greater than or equal to. Okay, remember those. Keep those in mind as we go through the rest of these lessons. As we go through the rest of this lesson. Goodness. All right, let's look at problem 1. So with each of these, your steps are going to be first to read the problem. Second, you're going to figure out what the problem is asking, write out that part, and then after you do that, finish the setup. So let's read the problem. The perimeter of a rectangle is at most 30 centimeters. Two opposite sides are both 6 centimeters long. Write and solve an inequality to find the possible lengths of the other two sides. So I see, and this is what I recommend. I recommend you guys take a highlighter or something like that, or use your draw tool and underline what it's looking for. It's looking for, we're trying to find the possible lengths of the other two sides. That's our goal here, the possible lengths of the other two sides. So let's start with this. It's given me a rectangle, and it's telling me that the two opposite sides, doesn't matter which two, it could be any two, that we have two opposite sides that are going to be 6 centimeters. So I'm just going to go here, and then the side opposite this, right over here, it's going to be another 6 centimeters. And then the rectangle is at most, it will not be greater than, it's at most 30 centimeters. It can be equal to 30 centimeters, but it will only go up to 30 centimeters. And let's see, is at most one of our signs? Yes, at most is one of our signs. If you look, it is the less than or equal to sign. So it's going to be at most less than or equal to 30 centimeters, all right? And now we're going to set up the rest of the problem and then solve to figure out what the possible length is of the other two sides. So we know that we have two sides that are 6 centimeters. So we know that's going to be a 6 plus a 6. We want to figure out what the length is of the two other sides. These two sides are going to be the same length. And so when we go to set that part of the problem up, let me scoot this over a little bit. When we go to set that part of the problem up, we know it's going to be another plus because it's the same. We're adding up the sides, its perimeter. And we're going to have not just one x, but we have two x's on the screen. So it's going to be a 2x, x plus x. And from here, we're going to perform our steps like usual. We're going to combine our like terms because there's a distribution happening. 6 plus 6 is going to give me 12. And I have plus 2x is less than or equal to 30. And now I'm going to move my 12. I'm going to isolate my variable term by subtracting this 2x from, not subtracting 2x, subtracting this 12 from both sides. And this is the color I want to use. So minus 12. Ooh. And then minus 12 on both sides. 12 minus 12 goes to 0. And what I'm left with here is this 2x is less than or equal to 30 minus 12 is going to be a 28, not a 28, 18. It's going to be an 18. And now I have this 2x less than or equal to 18. Now you guys are great with the song. You guys have that down pat. So you know to divide by 2 here. And what I have is going to be this x is less than or equal to 18 divided by 2 is 9. Now, I will say, going through the classworks and the notes that I have, that you all have submitted, I did see some mistakes, but a lot of them were simple mistakes dealing with just adding incorrectly or maybe distributing incorrectly or something like that. So you all are good with this stuff. You just got to be a little mindful when you're doing these things. What I did see, however, was some people were making mistakes with how to graph these. I won't graph this one because I'm pretty sure you all know how to graph this one. When our variable is on the left side, the way it is, we just graph it and our arrow faces the direction of the sign. You guys are good with this. You guys get a little confused when our variable is on the other side. So we'll cover one like that. All right, but this is it for number 1, problem 1. Our solution is x is going to be less than or equal to 9. So our rectangle, the sides for our x are going to be no more than 9. All right, now let's look at problem 2. Problem 2 says, the 9th grade students are selling chocolate bars for a fundraiser. Each student is encouraged to sell at least 12 chocolate bars. Pam sells 3 bars on Monday and 4 bars on Tuesday. Write and solve an inequality to find the possible number of bars Pam can sell to reach the goal. So go ahead, take a second, look at what it's giving us and think about what our goal is. What is it asking us to do and how we're going to start setting up the problem. All right, now that you've had a second to think about how to set the problem up, let us begin. I'm going to start by underlining what our goal is. Our goal is to write and solve an equation. We're looking for the number of bars Pam, let me switch colors. The number of bars Pam can sell to reach the goal. And it's telling us that each student is encouraged to sell at least 12 bars. So let's look up once again at our things up here. Nope, at least is right here under the greater than or equal to sign. At least, so we're going to start off with that greater than or equal to. We know we're going to have something is greater than or equal to 12 because they're asking Pam to sell at least 12 bars. Now let's look at the rest of the information that's given to us. She sells 3 bars on Monday. So that's something we're going to add. She sells 3 bars on Monday. And then she sells 4 bars on Tuesday. So she's sold 3 bars and then an additional 4 bars. How many more bars does she need to sell to get up to 12? That's what we're trying to figure out. And so plus X. We don't know how many more she has to sell. We're trying to find that. So now that we are here, you guys are great with this. Like I said before, 3 plus 4 is just going to be that 7. We're going to combine our like terms. That's our first step in solving these. We have the 7 plus X is greater than or equal to 12. And then from here, we're going to move the 7 over. I'll pick a different color there. Move the 7 over. And then our answer is going to be this x is greater than or equal to 12 minus 7. It's going to be 5. All right, any questions on this? If you have a question, go back to the Zoom meeting and ask me, okay? So actually, let's look at what this graph looks like. You guys are pretty good with these types of graphs, but I do want to have one in here just for you all to reference. Let's start off with a line, our number line. I'll go with that. And since it is a line, since it is a line, we're going to put arrows on it. And our 5 goes in the middle. And then we have not a 4. We have the 6 going to the right. Numbers that are bigger are to the right, and numbers that are smaller are to the left. I also did notice that a number of you all were not putting your numbers on your number line. Please do. We have this 5 here. This has a line underneath it. You guys are great at recognizing that. So since it has a line underneath it, since it is greater than or equal to, or less than or equal to one of those, it's closed. It is closed. So we're going to fill in this circle. And then since our x is on the left side, we can just go in the direction. A better way of thinking about that, though, and I talked about this in our last lesson, is that we're going to draw our line in the direction of values that satisfy the equation. So when we look at this, what numbers can we put into this x is greater than or equal to 5 that will satisfy that equation? We did this, and I had you all name numbers that were fitting with this inequality. 6, 7, 8, 22, 59, all those numbers that are greater than 5 that are to the right of 5 satisfy that equation, okay? And that's how we're going to draw these from now on. Not necessarily pointing in the direction of the sign, but in the direction of numbers that satisfy the inequality. All right, let's look at number 3. Number 3 says, Miss Lee has a reward system in her class. When all of her students behave well, she rewards them by drawing 7 stars on the chart. When the chart has 200 stars or more, the class has a party. Right now, the class has a party. Right now, the class has 28 stars. Write and solve an inequality to find how many more times the class needs to be rewarded to earn a party. So we are looking for how many more times the class needs to be rewarded to earn a party. That's our goal. And we're starting with seeing that they need to get up to 200 stars, up to 200 stars or more. The minimum that they can get is 200. If they get over that, that's great. But they have to get at the very least, at least 200 stars. So let's look up above. And at least is one of our things. So we're going to be using that one. So knowing they need to get at least 200 stars, we're going to go with this greater than or equal to sign. 200 stars or more means at least 200 stars. And so we have that greater than or equal to sign. And then we're going to write out the rest of the information that's given to us. Excuse me. She rewards them by drawing 7 stars on a chart, and they currently have 28. So they're starting this part off with 28 stars. They have 28 stars. 28 stars. And then they get an additional 7 stars each time they get rewarded. How many times they've been rewarded? I don't know. That's what we're trying to figure out. How many more times does the class need to be rewarded to get this party? That's going to be our variable. That's our unknown. And now that we have this set up, you guys are excellent. Go ahead and solve this on your own sheet of paper. Make sure you are writing your work for these things, okay? As you solve them, I will now start to solve them. We have this 28 over here, so we're going to move this via our inverse operations, our subtraction property of inequality. Subtract 28 from both sides. And then what we have left is the 7x is greater than or equal to 200 minus 28 is going to be a 72, right? And now we have the 7x is less than, or 7x is greater than, excuse me, or equal to 72. Okay. Oh, not 72, 172. And let me just check to make sure. 200 minus 28, that in fact is 172. You guys are free to use your Desmo Scientific Calculator. That'll be useful for these parts right here. And so now that we're at this step, we know that we got to get this x by itself. And the way to do that is going to be to perform our opposite operation, which is going to be divided by that 7. And now we have this 172 divided by 7. And what we're left with is this x is greater than or equal to 24.57. 24.57. And it's got a bunch of other decimals behind it. Just cut it off and round at the second decimal. And so while this would be the correct answer, think about it. Is this reasonable? Is Miss Lee gonna stop class right at 24.57 times of the students getting rewarded? No, she's not. She's gonna take them all the way to the 25th time, okay? So these problems, these real world application problems, you have to think about them a little bit and put down answers that are reasonable. Put down the exact answer that you get, but then also put down an answer that's reasonable for the question that's being asked, okay? So Miss Lee isn't gonna stop them in the middle of that 24.57 times of getting rewarded to give them the party. She's gonna do it on the next class, all right? So let's look at number 4. Mr. Hunt has at most $150 to spend at Game World. He wants to buy a video game that costs $42.75 and a game controller that costs $28.50. Write and solve an inequality to find the possible additional amounts Mr. Hunt can spend. So we're trying to see how much money does he have to spend outside of this $42. Where's my, and outside this $42 and a game controller that's $28 and change, okay? So he has at most, so let's go look up top again at our word bank. He has at most. So that's going to be this less than or equal to sign. Let's get back down to number 4. All right. So at most, so it's going to be a less than or equal to, and at most he has $150. So at most $150. It tells us that he has $42.75. That's how much he has to spend on a game that he wants to spend on a game. Then he has another $28 to spend on a controller, okay? So now he's got a $28.50 plus $28.50, oops, 28.50. And now we need to figure out how much more does it have to spend on anything else in the store. All right. So now that we're at this step, we are going to combine our like terms, and I'm going to type this in to see what I get. You get a 42.75 plus this 28.50. That's going to give you a 71.25 plus x, don't forget that, is less than or equal to this 150. And there we go. We've set the problem up and we've begun the process of solving it. So now my next step, you guys know my next step already. You guys are awesome at doing this. Ooh, different color. I like to use this color when writing out my math steps. 71.25, subtract it from this side, and then 71.25, subtract it from that side. This goes to 0. And now I have this x. is less than or equal to, and this 150 minus 71.25 is going to give me a 78.75. So Mr. Hunt has that much more money to spend anywhere in the store, okay? That much money to spend anywhere in the store. All right, so I'm going to do one more problem, and then I want you all to start working on these yourselves, okay? And if you have any questions, once again, go back to the Zoom chat and ask me. Samantha needs an average of at least 70. Okay, Samantha needs an average of at least 70 on her 3 science tests. She has already scored 60 and 85 on 2 tests. Write and solve an inequality to find the minimum grade Samantha needs on her 3rd test. So we are trying to find the minimum grade she needs on that 3rd test, all right? The minimum grade she needs. So let's look up to see what, is that one of them? The minimum, the smallest grade that she needs. And the minimum isn't one of the ones that we have in our word bank that's right up at the top. So we're going to have to think about this for a little bit, okay? If she is trying to get a minimum of 70, that means the lowest that she needs is a 70. Could she get something higher? Yeah, she can get something higher. Can she get something lower? No, she does not want anything lower than a 70, a minimum of 70. So 70 is the smallest amount she needs. So anything she gets has to be greater than or equal to that 70, all right? And she's already got a 60 and an 85 on her test. So we know those are going to be 2 of our given values. She got a 60 and she got an 85. And she's got one more test left. So what does she need to get on this last test? That's what we're trying to figure out. So we have this 60 plus this 85. We're going to go ahead and add those 2 together. Oops, I don't need to draw that. That's another equation. All right, 60 plus 85, that's going to be a 145 plus x is greater than or equal to 70. And now we're going to take this 70 and subtract let's back up one second, because this is a really easy way to make a mistake. She needs a 170 on 3 of her tests, all right? So for each test, she has to have an average of 170. So instead of just having it all 3 add together to be 70, that wouldn't be correct. And that's where a lot of students would want to make that mistake. Instead, because it started to look funny to me, she needs to have all 3 of them. When we take an average, you add things together and then divide it by however many there are. And so the average of all 3 of her tests need to come out to 70. So she needs to be able to add all 3 of her tests up, divide them by the 3 of them that there are, and it needs to be a minimum of 70, okay? And so after adding all of those up and dividing by 3, her score needs to be greater than or equal to 70. So this is why we want to take our time to understand what the question is asking, okay? I was moving just a tad bit fast and missed that little step initially, but I caught it. No problem. If you guys missed that little step initially, but you catch it, also no problem. So my first step actually isn't going to be to do that. It's going to be instead to multiply by 3 on both sides to get rid of this fraction. So times 3 on this side and times 3 on this side. And now I have the stuff I had before, the 60 plus 85 plus x is equal to 70 times 3 is going to be 210. And now I begin the process of solving like I was about to do before. I'm going to add these two up, this 65 and this 80, or this 60 and 85. And that's going to give me this 145. Oops, 145 plus x is greater than or equal to 210. And this is this stuff, but at this step, you guys are pros at getting this stuff now. And if you're not, no problem, let me know and I will walk you through the process, all right? We're gonna subtract 145 on both sides. 145 minus 145 goes to 0. And I have this x is greater than or equal to 210 minus 145 is gonna give you 210 210. Goodness. 1 second. 210 minus 145 is going to give you, once you do those, you're going to get a 65. All right. A 65. And so Samantha needs a minimum score. At the very least, she needs to score a 65 to get an average of a 70 on her test. All right. So this is how we're going to go through the process of setting these up. First, you're going to identify what they're asking you to solve for. Then figure out that whether it needs to be greater than or less than or equal to all that stuff. You're going to figure that step out. Figure out the left side or the right side of the equation. Once you get that, then you're going to add in this stuff to the right side based off of what they give you. All right. Those are the steps we're going to take. So go ahead. And I believe there are 4 more problems, 6, 7. Oh, no, 3 more problems, 6, 7, and 8. Go ahead and get started on those. If you need assistance, let me know and I will help you. When you are finished with those, submit them and we will go over them. Okay.